and then see what we know. All right, so hopefully a lot of these are just quick, short, big picture ideas. So for these first couple, I'm just wanting you to look at either the graph or an equation and then determine if it's quadratic, linear, or exponential. So that's all we're doing here. If we were to look at this number 1 here, hopefully we understand that a U-shaped graph, that's our new shape. We wouldn't have dealt with the U's last year, and our new function is a quadratic. So based upon a graph, if you see a U-shaped graph, we know that's going to be a quadratic without any real work done to it. 2, if you don't know this one, you have bigger issues to worry about here. This is a line. So that's the whole meaning of the word linear. That's why the word line appears in that word. So if you see a line, we know it's a linear function. All right, so those are kind of self-explanatory. Those, don't miss those. Number 3, there's a little typo here. Change this, as I was looking this over earlier. Change this to a positive 3 here. And then tell me what you think this is. So try that real quick. These now do require a little bit of work. Oh, no. The next one is the error. Sorry. I thought I had marked it. Yeah, that one's good. This was the one that had the little error to it. So number 3, go ahead. Don't change that to a negative 3. Leave it a negative 3. And then see what kind of pattern we have and then what sort of a function we're dealing with. All right, Jennifer, what do you got there, Jennifer?
I didn't finish it.
No, okay, go ahead. We're just looking to see, did we have anything, what sort of pattern, if anything, did we have? What are we doing? Good. We're adding 2 over and over and over again. That's what we call a common first difference. Do you remember what we call that in terms of a function, Jennifer? Which one of the 3? Good. So that means we're dealing with a linear equation. So all those things I'm going to ask again, common first difference, linear, okay, know those words, know those phrases. All right, number 4 was the one that has the typo. Make this into a positive 3 here. So change that to be a positive 3 on your sheet if you have it. And then same thing, look for the pattern. Is there a common first difference? Is there a common second difference? Is there a common ratio? And then that would tell us which of the 3 functions that we're dealing with. All right, and let's do Cam. What do you got there, Cam?
Common second difference of +2.
Okay, good, because when we go down here, what did you say for this one, Cam? The first interval?
-3.
Good, and then the next one we did what?
-1.
Good. Next one?
+1.
Good. And last one?
+3.
Good. So we know it's not a linear equation. We know it's not exponential. We don't have a common difference or ratio. But then what he said is we have a common second difference of what we're doing each time in this next set here, Cam.
Adding 2.
Good. Adding 2, adding 2, adding 2. So we have what we call the common second difference. That means we have a what, Cam? What kind of a function anyway?
Quadratic function.
Good. Quadratic. And then one more, just make sure we understood this. So when I give you this tomorrow, tell me what this next term would then be. See if we understand that pattern and how we found those. For the most part, we did pretty good on this question on our quiz, but be prepared to do one of these again. All right, and Walker, what do you think for the x value of 3? What would our y value be? Walker.
Plus 5. 5.
Good. So this will increase by 5 because we got to have a common difference of 2 here. So what numerical value do we get here?
8.
Good. So then we would get an 8. And just, if I give you a couple down the road, just know the pattern so that we can predict what would happen further on. Okay, good. Okay, 5 should be quick and easy. All right, go ahead and do that one. And then you can see, go ahead and tell me what the 6th one would be. Probably would need a calculator for that one. I know I do. All right, and let's do. Christian, up in my upper right-hand corner there. What do you think there, Christian? Common, or what is it? Linear exponential. Although he might be frozen. Mr. Kubitz, he's not moving. There's really good at not blinking. Cam, go ahead. You go ahead.
Okay.
Oh, is he? Okay. What do you got there, Christian?
Yeah, my camera is not working.
Okay.
Would this be exponential?
It would be. Thank you. And why is it exponential?
Because you're multiplying by 3 every time.
Good. Multiplying by 3, multiplying by 3, multiplying by 3. If I'm asking you to explain something, or multiple choice, all that good stuff tomorrow, I would use the phrase common ratio. That's what happens if we're multiplying repeatedly. So understand that phrase. And then this is the easier type. We just continue to multiply. So 3 times 243 would be 729. All right? Good. All right, let's say I give you equations. Can we recognize what equation is linear, what equation is exponential, and what equation is going to be a quadratic? All right, so if I give you these, do 6, 7, and 8. There's no work here. We just look at the equation, identify is it linear, exponential, or quadratic based upon certain characteristics. All right, and Nora. What do you think, Nora? Do you know all 3 of them? Do you know one of them? What do you know of 6, 7, and 8? What do you think?
Well, I started at 8. I said that 8 was quadratic.
Good. So good. Start wherever you're most comfortable. And why did you start at that one? What did you know about that one?
Because I knew when the x had a for quadratic, that's how it's set up.
Yeah, the x is what power? What does the x have a power of? Good. So when we see this here, the x getting raised to a power of 2, she knew that first and foremost meant that it was a quadratic. All right. Could you distinguish between the other 2 then?
I think that the number 6 would be linear.
Good.
And then 7 is exponential.
Good. Yeah. And how did you determine those, or are you not sure?
Because for 6, the x, I know that for 7, the x is squared, like it's to the power of x.
Good.
And then for linear, you don't do that. It's just normal.
So the reason it's exponential is because the x is your exponent. If the x is your exponent, that's why it's called an exponential function, because it's the exponent is your variable. Linear, one of the things we would have talked about last year, it has to have a power of 1, and that x has a power of 1. So that's how we would know that's going to create a line. All right. So tomorrow you're certainly going to get, here's just the equation. What do you think? Is this linear, exponential, or quadratic? And those are kind of the key points that we want to worry about. Here the exponent is a 1. Here your exponent is the variable. Here your exponent is a 2. Okay. All right, the next of these, just simplifying expressions, distributing if we need to, foiling if we need to, and then definitely combining some like terms. So all you're going to do, write each expression in simplest form. So what we had talked about, what we have done before, if we have like terms, so in this case, a 4x and a 2x are like terms, we can go ahead and combine those, and we end up having 6x's. If we do our like terms with a 10 and the -4, we can go ahead and combine a 10 and a -4. Those combined give you a +6. And then that's it. They're not like terms. That's really just how we leave our answer, 6x plus a 6. 10. First time I've given you one with this little teacher trick here to see who falls for this. Try number 10 real quick and see what you think. Okay, and then the reason this one sometimes is a little bit sneaky, there are some people, so if you did this, make sure we get this corrected for future reference. We don't want to add those first. Don't do 3 plus 7 first and then distribute. We're really just following your old phrase of, order of operations here, the whole PEMDAS idea, that you need to multiply before you're going to be adding. So the first thing we have to do, we can't add the 3 and the 4 together first. The first thing you need to do is multiply. And by multiply, I mean we're distributing that 4 to the quantity 2x minus a 1. So the 3 just gets dropped. And when we distribute, you'll get the 8x minus a 4. Now that you've done the multiplication element of this, now we can go ahead and add them all up, combine our like terms. So you're going to have 8x is by itself. And then if we take our common terms of 3 and the -4, add those guys up, should get to be a -1. So we would get 8x minus a 1. All right. $11, I'll leave you. I'm going to hope we can do that. I know we can do that. 12. This is our binomial multiplied by another binomial. So what we talked about with these, you got a few of them here, number 12, where you're going to take this x and we need to distribute it to every term in the other quantity. So when we do the x times the x, that's now when we get the x squared, when we're multiplying variables. And then the x times the +4 is a +4x. Once you've done that, now you take your 2, and the 2 needs to get distributed. So 2 times x will give you a +2x. And then the 2 times the 4 here should give you a +8. You should then see that you have like terms here that we can combine. So we should get x squared plus 6x and then plus 8. All right, real quick, 13. Make sure you can get through one of those on your own. So try 13. Definitely have to do this a couple times tomorrow. And this, the very last question on your quiz last time, this was the question that you had to upload your document to, and we did reasonably well on it. Let's just make sure we can do it. And let's see what we did. Take your 2x, that's going to get distributed. So the 2x and the x should have given you a 2x squared. Then take your 2x times a -3, that should be a -6x. 3 times x gives us a 3x, and then you take your 3 times a negative 3 to get a negative 9. The two middle terms, again, are like terms. Those are the ones that you're going to be able to combine. So we would get 2x squared. And then when we combine these guys here, a negative 6 and a positive 3 make a negative 3. So negative 3x. And then the constant negative 9 doesn't change. Okay? Any issues with that? Okay, good. 14. Haven't given you one of these just yet. Just follow your order of operations, though. We multiply before we add and subtract. So definitely here, hopefully not a problem. You're going to take your 4. We're going to distribute it to the x and the 2. So the 4 and the x would make a 4x. The 4 and the positive 2 make a positive 8. We then go to that second quantity. A couple different ways to approach it. I like to approach it by actually putting a 1 right here. So we know there is a negative 1 in front of that second quantity. That then requires us to distribute as well. So we now have to take this negative 1, multiply it by the 3. So we should get a negative 3x. Then the negative 1 has to get multiplied by the 9 to give us a negative 9. All right, so that minus sign, just understand, has to get distributed to both terms in that second set of parentheses. Now when we go collect like terms, let's do it this way. We have a 4x here. This is a negative 3x. Those are the terms that we're combining. So when we do that, that'll give us just a positive 1x. And then the constants are positive 8 and a negative 9. So positive 8 and a negative 9 should make a negative 1. So our answer would be x minus 1. Okay. Okay, next ones. Do that real quick. I think we've only done this once or twice, but let's make sure we remember how to do this. It's our function, so our function is f of x is equal to x squared plus 3x minus a 4. I want you to find f of 2. Little refresher on function notation. When you see f of x, whatever goes in these parentheses in the next step is the x value that we're evaluating this at. So we're really writing a point here, like x comma y. So when you look over here now, when I give you f of 2, what that's telling you is we're going to let our x be a 2. And when x is 2, what y value is that going to end up giving us? So we would come over to this function, and you're going to say f of 2, which just, again, means our x is becoming a 2. So on the other side, wherever you have an x, so notice where there are x's, I just have blank parentheses right now. Wherever you have an x, you're going to let your x become this 2. So I'll do 2 squared plus 3 times 2, and then take away the 4. Whatever that evaluates to be is what we're going to say f of 2 is equal to. We would get a 4 here, if I can sneak this in, 6 here, and then subtract that 4. If we then add these up, so we can kind of focus on what we're adding here, 4 and 6 would give us 10. 10 minus a 4 should end up giving us a 6, so that f of 2 would equal 6. It's a different way of writing a point. So what this really just means is when x is 2, your y coordinate is going to be a 6. That's function notation, just a different way of expressing points. All right. So 16, same idea, just a little bit different with the table. F of x, now I don't give you this equation, like you don't actually have an equation. you just have a table. But if we understand this notation, what this is saying is when x equals 5, what does y equal? So if you go to your table, find when the x coordinate is a 5. So the top row is your x row. If we come over here to where we get an x value of 5, the y coordinate at that point is this 8. So we would say f of 5 must equal 8. All right, we're really just looking at this point here. When x is 5, y is 8. All right. So 17, you have two options now. This one I do give you the function, so you do have f of x is equal to a negative x squared minus 2x plus 3. So we could, if I want f of 0, just plug in a 0. That's totally fine, just like we did up in number 15. Plug in the 0, whatever that evaluates to be is going to be your answer. In fact, let's go ahead and do that, just so we know. And then I'll show you the other way we can do this, which is probably quicker and easier. So wherever you have an x, plug in a 0. So this whole first term is going to go away because there's a 0 here. The second term is going to go away because you have a 0 there. All we're left with is a 3. Totally viable way to do that. If you have the equation, just plug it in. We could also use your graph though. If we understand this is saying that when x equals 0, and now asking you what's your y coordinate, all we have to do is, here's 6, 5, 4, 3, 2, 1. Here's the x value of 0. Go up to your graph. See how your graph is right here at this x value of 0? Do we all agree that the y coordinate at this point is the 3 that we got by plugging into the equation? Yeah. So we could just look at the graph. So if you go to 18, I mean, this is super easy to plug in. Well, let me do this first. So for number 17, tell me what this would be. Tell me what f of negative 2 would equal. And just use your graph. So just try to look at the graph and say, when x is a negative 2, what y value do you get? All right, so go to the x value of negative 2. So here's the x value of a negative 2. Here's the point on the graph at that time. We all agree that is also a y value of a negative 3, hopefully. Okay, so that's how you can use the graph. 18 is now the exact opposite. Now this is asking you, we don't know the x value now. That's what we don't know. So you're going to give me the x value when we have a y value of 2. So now here's your y value of 2. Look on this graph and determine where our y value is a 2. And that should be right here. That's when we cross this y value of 2. And what the question is now asking you in this format is, what is the x value at that time? So when we have a y value of 2, our x value is 1. I'm just kind of flipping it around there. Okay. All right. I think. Oh crap. These guys. All right. Yeah. So kind of look all these over. Just again a review. You know, that kind of increasing, decreasing. This is decreasing the whole time from 1 to 4. You know, just be able to identify when we're increasing, when we're decreasing. Couple other things. Be able to find a GCF tomorrow. I didn't necessarily put that on the review. That we've done multiple times, be able to do that. Be able to find a slope, whether it be from a set of 2 points or a line. And then just understand, you know, kind of interval notation. So the whole parentheses and brackets idea. All right, just the stuff we've been doing. So don't just rely on this test review. Look over your notes. Make sure we also know those items, because those things are going to be on there as well. All right, and by this I mean domain and range. All right. If you have any questions, just get on early. I'll log in a little bit early tomorrow. And if you wanted to hop in real quick, I'll cut my advisory short. Just come over real quick and we can answer any questions. Okay? Okay. All right. We'll see you guys. Have a good day.